Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. An oblique line is the one which is inclined to both the reference planes, that is horizontal plane, as well as the vertical plane. Since this line is inclined to both the reference planes, so neither of the front view or the top view they will be parallel to the XY reference line, and the projections of the line on the horizontal plane as well as the vertical plane, they will reveal the apparent length of the line, and we will not be able to obtain the true length of the line either in the front view or the top view. So in case we want to obtain the true length of the line in the front view as well as the top view, so therefore we need to apply the principles of rotation of the line method to evaluate the true length and the true inclinations of the line with the two reference planes HP and VP. In this case, we have been provided with a physical real life environment which we need to convert to projections of the oblique line, and thereafter using the principles of the oblique lines we are required to evaluate the true length and the true inclinations of this line with respect to HP and VP. So here we have got a room which is measuring 7.5 meter wide, 5 meter it is the depth of the room, and 4 meter it is the height of the room. So into this room we have got a fan suspended from the center of the ceiling. So in order to obtain the center of the ceiling, so we need to join the two diagonals of the ceiling over here. So this will be the point from where our fan will be suspended from the top of the ceiling. So this is the ceiling of the room, this is the floor of the room, and these are the four walls of the room. Now here we have got this fan. So this is connected to a switch. The switch is located in one of the corners of this particular room, and this fan, it is connected to a switch with the help of an electric wire or a cable, and the true length of this wire or the cable, it measures 5.5 meters over here. Now into this situation we are required to locate the appropriate height at which the switch will be located in one of the corners of the room, such that the true length of the electric wire or the cable which is going to join this switch with the center of the ceiling, so this should be equal to 5.5 meter long length over here. So this way we have to first of all draw the orthographic projections of this room, and then we have to locate the location of the projections of this particular cable in the front view, that is A dash B dash, and the projections of this cable in the top view, that is AB, will be located. And this way we will be able to convert this physical real life environment of the room into the projections of the line method, and we will be evaluating the appropriate height at which this switch should be located within this room, so that the length of this cable which is going to join this switch which is located in one of the corners of this room, and the electric fan which is suspended from the top of the ceiling. So this length, AB true length, it is given to us as 5.5 meters. So here we are going to use the scale of 1:100 in order to draw the orthographic projections corresponding to this particular room. So 1 meter we are going to represent as 10 millimeter over here. So the width of the room 7.5 meters, it will be represented as 75 millimeter in the orthographic projections. Similarly, the depth of the room, which happens to be 5 meter, will be represented as 50 millimeter in the orthographic projections, and the height of the room, which is equal to 4 meters, will be represented as 40 millimeter in the orthographic projection. Similarly, the length of the cable, that is the true length of the cable, which happens to be joining the switch with the center point of the ceiling, will be represented as 55 millimeter in the front view as well as in the top view. So using this information about the true length, we will be able to obtain the front view projections, that is A dash, B dash, and the top view projections, that is AB, in the orthographic projection. So when we look at this particular room from the front, so we observe that the front view projections will be width and the height. So width happens to be 7.5 meters and the height is 4 meters. So the front view orthographic projection will be represented by a rectangle measuring 75 millimeter width and 40 millimeter height. Similarly, the top view orthographic projections corresponding to this room can be drawn by using a rectangle which will be measuring 75 millimeter width and 50 millimeter, it is the depth of the room. So 75 by 50 millimeter rectangle will be representing the top view of this room. So with this information, we are required to obtain the projections of the line AB in the front view, that is A dash, B dash, and the projections of this line in the top view, that is AB. And we are also required to evaluate the height of the switch above the ground. So into this corner, what will be the height of the switch, that we need to obtain into this particular problem. And finally, we will also be evaluating the inclinations of the true length of this cable or the electric wire with respect to the horizontal plane, that is angle theta, and the inclination of this true length of this cable AB with respect to the vertical plane, that is the angle phi. Now let us proceed with the construction of the orthographic projections of this room. So we know that in the front view, we are going to get the width equal to 75 millimeter and the height is equal to 40 millimeter. So the front view will be represented with the help of a rectangle which is measuring 75 millimeter, it is the width, and 40 millimeter, it is the height of this particular room. Now this is the front view orthographic projection of this room. Similarly, in the top view, we are going to get the width of the room equal to 75 millimeter and the depth of the room, it is equal to 50 millimeter. So this is 75 millimeter, which is corresponding to the width of the room, and the depth of the room happens to be 50 millimeter. So this is the construction of the top view projection of this room, and this is the front view orthographic projection of this room. Now we know that the ceiling fan has been suspended from the central point of this particular ceiling. So in order to obtain the central point, we will be joining the two diagonals of this particular ceiling. So here we have got the projection for the ceiling, that is the top view. So the two diagonals of the ceiling we have joined over here. It means that when we look at this particular room from the top, so point B will be projected in the top view at the center. So small b point will be located over here. That is the top view corresponding to the ceiling fan. That is point B. It will be located over here. Similarly, when we are going to look at the switch, we do not know the height at which this switch should be located. But we know that this switch is located at an appropriate height along this particular corner of this particular room. So when we are going to look at this particular switch from the top, so this point A, that is corresponding to the switch, irrespective of the distance at which it is located above the ground, this point A will be located into this particular corner. So in the top view, irrespective of this distance that we have to obtain in this particular case, we know that this point A, which happens to lie in this corner, it will be projected into the leftmost corner of this particular room. We will be getting point A over here and point B at the center point. So this point A, it corresponds to this corner, which is the location of the switch in the top view. Similarly, this point B, it is corresponding to the point of suspension of the ceiling point from the center of the ceiling. So this point B has been located. Now, the moment we locate point A over here, so we know that point A dash will be located alongside this particular vertical projector line over here. Similarly, since point B has been located over here, that is at the center of this particular top view, so we know that point B dash will be located alongside this particular vertical projector in the front view. We know the orientation of location corresponding to the point B dash and corresponding to the point A dash over here, right? Now, we know that this is the apparent length of this particular cable as it appears to an observer who is going to look at this cable from the top. But another information also we have got. What is this information? This information is the true length of this particular cable. So we know that the cable of length 5.5 meter, it connects a switch directly to the fan at the center of the ceiling. So we know that this true length, that is AB1 or AB2, this happens to be 55 millimeter. So we have to draw a locus line through the point A. We have to draw the locus line through the point B in the top view. So once we draw these two locus lines, now through point B, I have to draw the orientation of the true length over here. Now I know that the true length of the line happens to be 55 millimeter. So as per the rotation of the line method, the apparent length as well as the true length, they will lie between these two locus lines over here, which are going to pass through points A and points B. So now we can see that through point B, I am going to open my compass and I will be marking a distance of 55 millimeter starting from point B onto the locus line, which is going to be passing through the point A over here. So once I measure this distance is equal to 55 millimeter, I obtain the point A1 over here. So point A1B, this represents the true length of the line AB into the top view. So this true length has been obtained over here. Now, once I obtain this true length, another thing, I also know that the locus line corresponding to the point B dash will lie over here. That is, from point B, if I draw a vertical locus line, my B dash point is going to lie over here. Now, as I look at this room from the front, I know that this is my ceiling point, and into the ceiling, this is the location of suspension of the ceiling fan. So it is this point which can be easily located even in the front view. So this will be the midpoint of the width over here. So this is the width of the room, which happens to be 75 millimeter. So if I project this point B in the front view, so I'll be able to obtain this point B dash over here. Please check. Point B will be projected in the front view because I know the location of this point B into the ceiling. So this is the point of suspension of the fan, which is lying at the center of the ceiling. So center of the ceiling has been located. Corresponding to this at the ceiling, point B dash has been located. Now, in the front view, only one point remains unknown over here. It is this point A dash. So I do not know the location or position of this point A dash in the front view. The reason why? The reason is because I do not know the height at which this cable, which is going to measure 5.5 meter, that is 55 millimeter over here, it is going to intersect with this corner point over here. So wherever this particular true length of the cable is going to intersect with the corner point, I will be able to obtain this particular height or the location of the switch into the corner of the room. So in order to obtain the location of the point A dash, now once again the principles of the rotation of the line method have to be used over here. Now please check. I know that I have been provided with the measurement of the true length of this cable or the electric wire, and this measurement happens to be 55 millimeter. So once I know the true length of this particular line or the cable A1B, so I know that I will be able to obtain this true length in the top view on the horizontal plane only when my elevation projection line, that is A dash B dash, happens to be parallel to the horizontal plane. So please check, if my projection elevation line A dash B dash happens to be parallel to the horizontal plane, only then I will be able to obtain the true length of this line in the top view, that is onto the horizontal plane. So usually what we do, we have already got in most of the cases this projection line and we obtain this particular true length, but in this case it is the vice versa. Here we have been provided with the true length of the line in the top view. Now the reverse procedure has to be used over here. So since the true length of the line is available with us in the top view, now what we have to do, from this point B, we have to take a vertical projector up to the locus line of the point A dash over here, so that our projector in the elevation should become parallel to the horizontal plane. So this procedure needs to be followed in this particular case. So here we have got point B dash is already located, point A dash needs to be evaluated. So what I am going to do, here I have got a line A1B over here, which is the true length. So what I am going to do, through this point A1, I will be drawing a vertical projector which will be moving up to the locus line of this point B dash over here. Through this point A1, I have drawn a vertical projector upwards till it meets the horizontal locus line corresponding to the point B dash. So this was point A1. So corresponding point in the elevation which I am going to obtain, this point name will be A1 dash. So from projection of points, point A1 dash and point A1, they will be lying in one vertical line. So through this particular construction, we have been able to obtain A1 dash B dash front view projection parallel to the horizontal plane. So this really validates this particular aspect of the rotation of the line, that since our front view apparent length projection happens to be parallel to the horizontal plane, so this has resulted in obtaining the true length of the line in the top view. Now since true length was available, so by projecting it upwards, we have been able to obtain the apparent length projection in the front view parallel to the horizontal plane. Now what we need to do, I know that A point lies here, A dash point will be lying along this vertical projector line. So what I am going to do, I have got this horizontal projector line passing through points A1 dash and B dash. So now what I am going to do, B dash will be my locus point. or my needle point, I'll open the compass equal to A1 dash B dash and rotate it back so that this point A1 dash can be transferred alongside this vertical projector line onto which point A dash needs to be located. So once I keep my needle point at B dash, open compass up to the distance A1 dash B dash and rotate the point A1 dash in such a way that it should intersect with this vertical projector which is going to pass through point A, and wherever this curve it is going to intersect with this vertical projector, I am going to get the location of the point A dash over here. It means that I will be able to obtain the height of this switch above the ground over here. This is my point A dash. So point A dash is going to define what? It is going to define the height at which my switch should be located above the ground. So the moment I locate this point A dash, now I can join point A dash with B dash again using black color. So here black color represented the apparent length. So this is the apparent length projection corresponding to this electric wire or the cable in the front view. So the moment I obtain this distance A dash B dash, so automatically this height of the switch I am able to locate over here. So once I measure this distance, I am able to evaluate the appropriate height at which this switch should be located. You can check, this is the height at which the switch should be located such that the true length of this distance should be equal to 5.5 meter. Now this switch is going to join with center of the ceiling over here. So the apparent length I have been able to project in the front view in this particular case. So in order to validate this solution, another thing I am going to do, I am going to check that I have already got the apparent length projection of this particular cable in the top view. Now by using the principles of rotation of the line, what I am going to do, I'll make this projection parallel to the vertical plane. The projection of the top view, we are going to rotate this AB projection of this cable in the top view. So once we rotate this and make it parallel to the vertical plane, so we are going to obtain the true length of this line in the front view on the vertical plane. So now you can check, I am going to rotate this projector through this point B. So at point B will be my needle point. I'll open my compass equal to the distance AB and I'll be rotating this point A up to the locus line corresponding to the point B so that my projector in the plan A to B, it becomes parallel to the vertical plane. Here you can check. This projector becomes, this is A2, this is B. So A to B becomes parallel to the vertical plane. So in the front view on the vertical plane, now I will be able to obtain the true length of this particular line. And I already know the true length. So this true length should work out to be 55 millimeter. So if I work this out equal to 55, it means that my solution will be accurate one. So through this point A2, now you can check, we have drawn a vertical projector over here up to the locus line corresponding to the point A dash. And wherever these two projectors they intersect, now point A2 dash will be located over here. This is the location of the point A2 dash. Now I can join this point A2 dash with point B dash and I find out that this distance between A2 dash and B dash, this happens to be 55 millimeter. That is corresponding to 5.5 meter true length of this cable or the electric wire over here. So this way I have been able to validate that the principles of the rotation of the line have been applied appropriately in this particular case, and I have been able to evaluate the distance of this switch above the ground into this particular corner of the room over here. So this way, having drawn the projections using black color in the front view, that is A dash B dash and AB in the top view, and having drawn the true length of the line in the front view, that is A2 dash B dash, and in the top view, that is A1B. Now we can also measure out, or we can also evaluate the angles of inclinations of these apparent lengths and the true lengths with respect to the two reference planes. So alpha, it is the angle of inclination of the apparent length in the elevation with respect to HP. Similarly, theta is the angle of inclination of the true length of this line with respect to the horizontal plane in the front view. Similarly, angle beta, it is the angle of inclination of this apparent length in plan with respect to the vertical plane, and the angle phi, it is the angle of inclination of this true length which has been drawn in the plan with respect to the vertical plane. And we can check that the true length of the line which has been drawn using the blue color, it happens to be greater than the apparent lengths of the line which have been obtained in the front view as well as in the top view, and the apparent angles, they are greater than the true angles of inclination. So alpha, it is greater than theta, and beta angle happens to be greater than phi. So this way we have been able to evaluate an appropriate height into this corner at which our switch should be located, such that the distance between the central ceiling point, suspension point of this fan and the location of the switch, so this distance should be equal to 5.5 meters. So using the principles of the rotation of the line, so we have been able to evaluate this particular height of the switch, and we have been able to validate that the given true length, it is equal in front view as well as in the top view. So this is all for today. So I hope that through this discussion you would have understood that how you can go about converting a real life situation into the projections of the oblique line, and then subsequently using the principles of the rotation of line method, how we can obtain the desirable height of the switch in the corner of this particular room. So we'll be continuing with further discussion on few more illustrative cases like this in the coming lectures. So thank you very much. Thanks a lot.